All right. So we got one of our hopefully our last video, but maybe we might need to do one more. Okay. We'll see how long this one goes. I'm not quite sure. So anyway, today we're talking about inverses. All right, functions, inverses, and their inverses. This is going to be a fun day. I'm telling you right now. It's going to be one of the last videos for Unit 2. Okay, such a sad day. All right, so let's talk about a function and its inverse. Okay, a lot of this first part is just kind of me talking and you listening. I'm going to write some things down. You should write some things down as well as I write them down, and write down things that I say that maybe aren't even listed on the piece of paper. You know, that's always a good idea, note taking. First, a function g of x is said to be an inverse if and only if f of g of x and g of f of x is equal to x. So when we're talking about, all right, we're talking about the composition of these two functions. If I have two separate functions here, all right, they are only said to be inverses if the composition of those two functions, okay, is x. My answer comes out to be x. All right. If this condition holds, then g is called the inverse of x. F of x, excuse me. G of x is called the inverse of f of x, and we'll denote that as f prime, or f inverse, excuse me, f inverse of x, just like that. Okay. A function has an inverse if it is one-to-one. So what does that mean? Okay, being one-to-one means one in and one out. All right, it means, you know, a function is one-to-one if every output corresponds with exactly one input. Okay, really a function, first of all, has to be a function. We know what a function is. It has to pass the vertical line test. Okay, for every input has exactly one output. Well, now, in order for a function to be one-to-one, in order for a function to be eligible to have an inverse, it has to have every output must only correspond with exactly one input now, okay? In order for a function to have an inverse or be considered, not necessarily have an inverse, but, you know, to pass this to be one-to-one. Okay, what is, a function must pass the horizontal line test. Remember, when deciding if a function is a function, it passes the vertical line test. So deciding if the function can be an inverse or have an inverse, it has to pass the horizontal line test. All right, so a function that we're used to dealing with is a parabola, an x squared term, and that's a rough sketch. So on a parabola, I have this point A, and it hits the graph at, let's say, B on the y-axis. Well, not only does it hit the graph here with A, but it also can have, B can also have an input of C. All right, so I can have A having the same output as C. Well, this function here would not pass our horizontal line test. Okay, if you look here, our function, ooh, maybe that could like actually work. Maybe one time we'll see for the kids. Okay, definitely not. All right, definitely not. Got a battle. So if I click and drag this, wow, how about that? If I click and drag this, it hits, my function hits that horizontal line twice. Okay, so, you know, the rule where one output can only correspond with exactly one input, that does not hold true here. So if we were to find the inverse of this function, we need to set some restrictions. Okay, an example here, let's say I have the square root function. Okay, our square root function, for every one input, there's only one output. All right, there are no other inputs that have an output of, let's say this, again, this is A and that's B. All right, there's no other inputs that have an output of B. So again, my horizontal line test, all right, if I want to test that, you'll see that only my red only meets the black ones. Okay? Went through that kind of quickly. How about that? Oh, it'd be helpful if this was in here, wouldn't it? Yeah, for sure. Okay, so if a point, this is important, all right, if a point lies on the graph, if AB lies on the graph of f of x, then BA lies on the graph of f prime of x. And what that means is the domain of our function is the range. Oh boy, about that got a little jumpy. The domain of our function is actually the range of our inverse, and the range of our function is the domain of our inverse. So if you think about it, like if I have x comma y here, okay, x comma y, right? Well, now my y becomes my x, and my x becomes my y. Okay, that makes sense mathematically. Okay, it said that I just said this actually. It said that the graph of f of x is reflected over the line y equals x to create this f prime of x. So what that looks like is if I have here's a coordinate plane here. I'm going to draw a line through it, y equals x. We're just going to imagine that's perfect. Okay, if I have this graph here, let's say again we'll go back to our square root function. All right, that looks like that. Okay, that will be reflected over the line y equals x to be an inverse. Okay, this notion of a comma b. So let's say I have this point here. Let's say this was I have a point here. Okay. All right. Well, to find my inverse point, I would go over this much and up that much to make it right there, to reflect it over. Okay. Yes. So let's take this off for a second here. All right. So I can reflect that point. Okay. It's kind of like, remember we've talked about reflection over the x-axis, reflection over the y-axis. Well, now we're talking reflection over the line y equals x. Okay. And that's why this notion here makes sense. This fact makes sense. The domain of f of x must be the range of f prime of x. All right. Yes. So if you look at, we're going back to our circles now. All right. So I have this function. Okay. I have x and I plug it in to f of x. So I apply, here's x. I apply f to get my function y equals f of x. Well, to go backwards from my function, I apply f prime of x. All right. Again, the domain of our function is going to be the range of our inverse, and the range of our function will be the domain of our inverse. Okay. So here we're given a graph, and we're asked to sketch the graph of y prime of x. So what I want to do, let's use a dotted line. All right, I'm going to throw a line through here that's about y equals x. Okay. And we're going to say, okay, well maybe let's say this was shifted over. Let's call this point 1, 0. Let's call this point 2, 1. Let's call this point 5, 2. So it's a square root function that was shifted 1 unit to the right. All right. So now, well, this point will become, we'll guesstimate here, 0, 1. Okay. This point would become 1, 2. And this point would become 2, 5. And our graph would look like that. And this red graph here would be our inverse. Okay? So f inverse would have these 3 points on there. All right? I'm interchanging my x's and y's on that. Hey, let's keep going. So again, we're just kind of going to blend these two together. All right? This is technically the second one, right? But we're powering through. The graph of f of x is reflected over the line y equals x to create f inverse of x. I've said that, okay? The point AB lies on f of x, and the point BA lies on f inverse of x. The domain of f of x must be the range of f inverse of x, and the range of f of x must be the domain of f inverse of x. Wow, this is a lot of like f of x and fx and sound effects. Wow, for sure. Okay, so this has a lot. These last 2 lines have a lot to do with this idea. All right. Oh, buckets. You know, things are just jumping today. We are jumping around. We're having fun with one of our last videos. All right. So we're given. This is supposed to say given, right? But given isn't spelled like that. Okay. This is supposed to say given f of x, find f inverse of x. Well, in order to do that, okay, we're going to write out some steps. We're going to write out some steps here. All right, steps to finding the inverse. There are 4, maybe 5 steps. All right, step 1. Okay, step 1. We're going to replace f of x with y. We always have f of x equals, let's say, in the last example is 3x minus 2. Well, we replace that f of x with y. Our next step is to switch all y's to x's and x's to, okay, y's. All right. After that, solve for y. Okay. What is that? Okay. Lastly, we're going to replace y. So once we have solved for y, we're going to replace y with function notation f inverse of x. Okay. A step that you will see sometimes, all right, or you'll ask to be you'll ask to do this. Okay, you'll be asked to do this for sure. Verify by composition. So take f of f inverse of x and f inverse of f of x. Okay, and see if you get x composition. So complete the composition of the two functions. All right. Okay. So let's apply this now to, I don't understand. Okay, whatever. All right, let's apply this to our function here. Or just do that. Oh, are you kidding? Alright, sorry. So before we do step one, we want to make sure that this function is in fact one-to-one, that it passes our horizontal line test. Well, if you look at any linear function, it's going to pass your horizontal line test. Alright, so this function is one-to-one, therefore it has an inverse. We do not need to set any restrictions. Alright, so our first step was to replace f of x with y. So y equals 3x minus 2. Second step, switch all my x's and y's. So it's now x equals 3y minus 2. Okay. Next step was to solve for y. So we get y by itself. Alexa's about that. Alexa was just really excited to talk to me. Now I bet it's going to happen again. So I add 2 to both sides. All right, x plus 2 equals 3y. Divide everything by 3. So y equals x plus 2 over 3. All right, our last step was to rewrite it in function notation. All right, using f inverse of x equals x plus 2 divided by 3. All right, now, if I think about this as a composition, if I were to plug x plus 2 divided by 3 back in for x, you would get x. X would be spit back out. All right, I'm not going to do that for the sake of time today. Okay, let's think about this function next. All right, this is our cubic function that's stretched vertically, all right, and moved down a little bit. This function, as you can see, all right, does pass the horizontal line test, therefore it's one-to-one, so we can get to work. All right, actually, I'm going to pause this here, okay, and I'm going to pick back up on it on the next video.